When you sit down to eat your next meal, think about how your food got in front of you. Did you grow it yourself or did you buy it from someone? If the latter, was it from a restaurant or a store? Do you ever wonder how it gets from the farm to your plate? Whether you're a vegan or a die-hard carnivore, your food comes from a farm somewhere. It needs to be grown, harvested, processed, and transported to a place where it is then prepared and offered for sale. This process can be anywhere from days to months and can come from down the road or across the oceans and continents far away. One thing is for certain, it probably involves one or more integrated circuits along the way. How could Microchip Technology help bring food from the farm to your table? Let's go beyond the microchip and hear a story of empowering innovation to enhance the human experience. Our guests today are Ross Satchell and Toby Sinkinson. Ross and Toby are applications engineers at Microchip Technology working out of the 8-bit microcontroller business unit. They join us today from our global headquarters in Chandler, Arizona. Welcome, Ross. Welcome, Toby. Thanks for joining us here on Beyond the Microchip. In the intro, we briefly talked about the food we eat and how Microchip Technology can make it easier to get from farm to table. Tell us about it.
So we've seen over about the last 20 years a real rise in the availability of microcontroller sensors, and during that time we've also seen the cost of them plummet. And so this enables small developers all the way through to large companies to develop embedded systems using low-cost sensors. And additionally, we've seen the rise of a lot of different radio technologies, everything from Wi-Fi all the way through to LoRa, which is a
long-range, low-power.
And LoRa in particular is a really power-sipping technology that uses very little current, has a very long range, but at the cost of that, it has a very low throughput. But that makes it perfect for these agricultural applications.
Yeah, in the Agri-IoT project that we developed, we were we installed it right outside here in Microchip and put it in the farm. We were at 500 meters, but LoRa in the city can go all the way out to 2 kilometers to 8 kilometers and still have good reception, especially when you're thinking about farms where you have not a lot of obstacles in the signal. So it makes it much more suitable there.
Right. So in the old days, you had a farmer. He probably had some kind of animal dragging a plow. And then if he ever needed to go out and look at the crops, he physically walked out to the field, bent down and looked at the crops. And we don't need to do that anymore, right? We have sensors, we have long-range power, we have a number of different applications to it. So what has become integrated circuitry that kind of replaces that analog process that the farmers of yesterday did?
So it makes the whole process much faster and more able to get a clearer picture of what's happening on the entire farm at any point in time, because by deploying a lot of sensors across the farm, you can get a really granular look at what's happening without the farmer having to go out and look at lumps of earth and look at individual plants. They still need to get that ground truth by going out and comparing that to the data that they're seeing, but it means that they don't have to go out anywhere near as often. And so more nodes just means a clearer picture of what's happening on the entire farm.
Yeah, so farmers in the past, right, would reach down with their hands. It's sort of a crude way to actually touch the soil. They could feel the texture, what critters were in it, that crudeness has been incredible, and we've relied on that for a long time. But now with having these sensors that are more accurate, more precision, have more precision, and you can place them in over these distances, it makes the whole application of visiting all these different places much more efficient.
So your modern farmer's sitting in his house with a laptop rather than walking around and letting his gut tell him how the crop's doing?
Well, it's a bit of both, because you still need to have that physical knowledge of what's actually happening and understand the what a particular element in the earth or of texture of the earth indicates, but also being able to understand the data analytic side of it makes them way more efficient, helps them improve their yields across the entire farm with less work on their behalf.
So the data analytics part, that's what gets us into the realm of smart agriculture.
That's correct.
Right. So what kind of analysis and insights do the farmers typically pull from the data?
Well, there's a couple of pieces there that need to be teased out. I think in our design, we were measuring soil temperature and soil moisture, but then above the ground you have humidity, barometric pressure to calculate weather patterns. There's a whole bunch of other things that you could be measuring there, and I think what farmers need often is not. You need to be able to synthesize that data in a very meaningful way that makes it very easy. Most farmers, we'll get into this later, I think, about, the modern farmer is younger, so they're maybe more familiar with or more accepting of technology in their space. But traditionally, and many of them, who have relied on these old methods, are not interested in being overwhelmed with data. So that machine learning piece there is, how do we take this data and make meaningful long-range decisions about the farm?
So sensors, power sipping, radio, that helps the farmer draw it out of the ground efficiently, and that helps the production and the yield. But then you got to actually get it somewhere. Then what happens?
So a big part of moving the produce that is grown often in rural areas to the cities where it's consumed usually means via truck. And so there's a lot of pollution problems associated with that because there's the carbon emissions of the fuel that's being burned. There's also the microplastics that are coming off the tires on the trucks that ends up on the ground. It slowly works its way into our water table and our water system, and then eventually it finds its way into our plants, which is far from ideal. So we kind of want to see if we can get the place where the food is grown much closer to the place where it's consumed. And so then we're starting to look at things like locally produced food within the community that it is actually consumed in.
Yeah, so and our project too, when we were working towards helping these small farmers have access to the kind of technology that could help them grow locally, because you have these, the big agricultural farms have, lots larger yields, they have bigger R&D budgets. To be able to put this technology in the hands of them means they can grow it closer, more locally.
And that eliminates the need for planes, trains, automobiles, and transport technologies.
It doesn't eliminate it, but it hopefully will greatly reduce it. Because I don't think we can ever eliminate large-scale farming, especially in very large cities, from the people where it's consumed, because you simply won't be able to grow enough food within a city. So, but if we can reduce that effect that all the trucking, et cetera, is having, then that's a good thing. But as Toby was saying on the community gardening side of things, where you're getting the locals involved in farming their food, and there's a lot of positive effects there. So you have people getting regular exercise and getting a healthy lifestyle. There's a sense of community where you can get to meet your neighbours and garden with them and talk about what's going on in their lives and actually get to know your neighbours, because how many of us in a city actually know our neighbours? There's also opportunities for learning, whether it's for children or adults or any ages, basically, where the kids can learn about, one, where their food comes from, two, they can learn about some of the embedded systems perhaps that are being used to help monitor everything, and just also learn from some of the older people in their community. And at the end of the day, it's all about making fresh food accessible to people in your local community.
Yeah, and that being closer means a lot of foods, fruit and vegetables in particular, the sooner you get it from the vine to the plate, the more enriching it is, the more delicious it is.
Yeah, so there's the time aspect, there's the social aspect. With regards to the technologies we've been talking about so far, does the size of the organization matter? I mean, is there any different use case scenario for a mega farm as there would be for one of these small community gardens?
That's a good question. The mega farms are often using a lot of embedded systems that are built into their combine harvesters and their planter machines and things like that, whereas a much smaller scale farm is often using people to do that and then just monitoring the actual conditions around the plants and the crops as they grow.
Is there a difference in data capture and analysis between the two scales?
You would expect that on a very large-scale farm that they would likely have a much closer idea of what's going on. But if their only source of data is coming from these large tractors, then they still get just a snapshot as it goes past the plants, or it's planting them, or it's harvesting and things like that. So if you're able to have these sensor nodes in a farm, then it really gives you not just that single snapshot, but many snapshots over time. And so you get a really clearer picture of what's going on in the farm.
I think with the larger farms too, you're often dealing with a monoculture crop. And so smaller farms are going to have a more diversified. So they have different kinds of needs in different locations, whether that's shaded or partially shaded or more water, less water.
And then we talked about the idea of a farmer with his laptop. That probably lends itself to opportunities for automation, right? So what's a brief kind of overview to touch? Because we're going to talk about this probably the next time we see you guys in a different episode. But what can you touch on briefly about the use of automation because of these technologies?
Absolutely. So there's a few different opportunities for automation. So part of it is the small-scale community gardening that we were just talking about before. Mm-hmm. There's also, for example, in New York City, I used to live in Brooklyn, and right at the end of my street on Eagle Street is a place called Brooklyn Grange, where they were setting up rooftop gardens. And so there's a lot of opportunities there because you have dual use, so you can produce food and you can also reduce the cooling requirements of a building. And that also offsets some of the problems with white roof, which is just painting the roof white so you reflect the sunlight. And there's some evidence that's suggesting that actually reduces the vertical transport of the moisture, and it reduces your cloud formation and thus rain. So that can cause some problems. But adding automation, because there's a tendency in agriculture to overwater things, because underwatering means that you could potentially lose the entire crop. So in that case, it's better to overwater. But the problem is it obviously increases your water consumption, but it also dilutes the flavor of some of these. For example, watermelon, if you overwater that, it really dilutes that flavor. You don't get that real nice sweetness. And having that excess water, or watering, that means that you have any excess is running off into local waterways, carrying your fertilizer with it. And that causes its own set of problems, known as eutrophication, which is the excess nutrients, in these waterways. And this causes increased plant growth, and also kills animals like fish due to the lack of oxygen in the water, since the plants are all taking up that oxygen. And this is why we've been seeing increased frequency of algal blooms. And so by automating things, we should see that we can get the right amount of water to each section of the farm, so that way we can optimize that. And the main idea is, 1, you reduce your water consumption, 2, you get the water to where you need it, and 3, you're minimizing the fertilizer runoff and affecting all the systems around you.
You know, to that I'd add too, and here in Arizona, one technique that farmers are using is flood irrigation. So they are each given this certain amount of time period where they can access the water from the waterway system. And so they open the one valve on the end, and they have to wait until that water reaches the end of the row, which can take maybe a couple of hours till it's fully saturated, and go out and turn that off, and then they open the next one. So this often happens at night too. So this is where I think they're really excited about having this automated, where we'd have some sort of sensor at the end of the row that we know exactly, and like buried a certain depth underground, so we know exactly when that water has reached that point, and they can automate this process.
We're looking for that Goldilocks zone, right? Not
Absolutely.
too hot, not too cold.
Yeah.
Yeah, you can see that when somebody's watering their lawn, when they've let the water go too long, and then the water just goes down into the gutter, and that doesn't help anybody save water, does it?
Yeah, especially here. I mean, all the restrictions on the Colorado River Basin here, people are becoming not only more mindful, and especially the farmers that we've talked to who are already on that. I mean, that's their livelihood, but also there's a bigger picture here with taking care of the water that we do have.
So that kind of gets into sustainability in modern farming, water conservation chiefly among them. Are there any other principal resources that we can think of with this technology that would help us save? You mentioned fertilizer.
So you can reduce, absolutely. You can reduce the amount of fertilizer that you're using, and also
the thing that popped into my mind, maybe a little tangent, but is all the technologies that we've been talking about so far that we're trying to bring to farmers require that we're not using very much power at all. They have to be able to do their task because with very little battery or possibly solar harvesting. Maybe that's another area that I think the technologies can help out with, just solar and other energy forms relate, like how farms can run off of these alternative power sources.
Because we're seeing lithium batteries in everything currently, and so one of the big problems is once the lithium battery, whether it's a primary non-rechargeable battery or a secondary rechargeable battery, at the end of its lifespan, ideally we need to be able to reclaim that lithium so that it can get reused. But as Toby was saying, if we can go to some form of renewable, for example, solar, in the form of, say, small solar cells and supercapacitors to power these devices, and this means we're looking at 20-year lifespans out of these embedded systems that are working out in the farm. They can pretty much just be left alone. And the only time you'd really need to pull them up is harvest time, so that you don't accidentally run them over.
So let's think about smart agriculture as a category. What are some useful ideas about smart agriculture? So we know that we want to save water. We know that we want to save fertilizer. What other areas are there to be aware of in terms of the old ways versus the new ways?
We touched on it briefly, at least with the farm-to-table concept too, and the supply chain, how that's working. Smart agriculture helps us reduce that time, reduce the resources involved in transporting that.
We've seen with the Internet of Things how it's already starting to change our lives a lot. And so it's ranging from everything from consumer health and fitness, if you're wearing some sort of fitness tracker, through to transportation such as Uber or accurate public transport. So I remember waiting at a bus stop 20 years ago for a bus that never came. And then we go into things like smart supply chains, where where is my shipping container, or tracking the temperature of a carton of milk as it travels all the way from the creamery to your local store, so you know whether it's stayed within the temperature range during that trip, and if it's gone outside of that temperature range, where has that happened? So then that can be addressed, and so those problems can be solved. And then we've seen smart homes. So for an example is one of the earlier episodes with Dr. Mark Smith and his espresso machine learning algorithm that predicted when it should turn itself on based on previous data. And you can control your lights. So you have, for example, a thermostat based on occupancy. So you can use a predictive model, or you can control it externally through your smartphone. We have fire detection systems that it's a smartphone. Then we have fire detection systems where you can have a smartphone alert if little Johnny or little Debbie is starting fires in their bedroom. And then also you can alert first responders and advise them where to position their personnel and their trucks so they can more safely control the fire, put it out, and also get their personnel in and out safely while getting the people who are trapped in the fire out. Then we have also smart cities. So we're seeing here in Phoenix, Arizona, smart traffic lights that are being used to reduce pollution by improving the traffic flow based on intersection camera data. And then if we can combine that with pollution sensing Internet of Things or IoT nodes at intersections, that can give you real feedback into the machine learning models. That way you can optimize the traffic flow to minimize these air pollutants.
I would add to that too that the changing weather patterns, we're seeing some pretty extreme weather and droughts, and that being able to respond to those changes in farming in maybe a way that they're not normally doing is going to be critical in order to keep up the yield that they need and take care of the crops that they have. Smart agriculture gives us a way to respond.
And so the Congressional Budget Office has predicted that the US population is going to increase by about 37 million people over the next 30 years. Now, this doesn't sound like much considering the United States has a population of around 330 million. But when we take into account that population increase with the water scarcity increasing, that leads to increased crop failures due to the spring and fall temperature shifts. Farmers' profit margins are getting thinner and thinner, making it more difficult for them to remain viable. And also the number of farms has been steadily dropping since 2007, basically since the GFC or global financial crisis. So all of that together, it means that the farms need to be more efficient. They need to maximize their yield while using less water, minimizing their runoff so they can protect the waterways. And also this means that they need a huge amount of data so that their systems can be optimized. And that means they need to be cost effective. So these smaller farms can afford to implement this data-driven farming so they can remain viable.
Lucky for them, too, that we're seeing a lot of this technology is more accessible to consumer level. So, and going back to your point, Dana, when you mentioned that modern farmer has the laptop, really the laptop is in their pocket. I mean, they're walking around with the phone. We've built these dashboards so that you can literally jump to a part of your crop and say, this is what the temperature is in the soil. This is what the humidity is there. And this is what it's been since 8 o'clock this morning, so.
And having those environmental sensors, not just the soil-based ones like the soil moisture and soil temperature, but the air-based ones where you have the temperature, humidity, atmospheric pressure, this enables you to identify microclimates on your farm that previously you would have had no idea that they existed. And this means that farmers may end up actually reorganizing their farm to take advantage of this.
Is this like an area where there's more trees versus less, or by a riverbed, and this is all done on the phone?
Or this is all done from the device that you can then track the data through any kind of computer, whether that's your phone or your laptop.
And obviously the pricing on the components is going down. So everything seems to be getting smaller, more efficient, and easier to work with.
Yeah, absolutely. Yeah. We've seen it in the...
Luckily.
Right?
Yeah, I mean, it couldn't come at a better time, right?
When I first encountered embedded systems in the mid-1990s, I remember saying, who would do this? Because it was so difficult to write because you had to do everything in hexadecimal. So that's right. So you start with your base address, and then you have to calculate your offset. You calculate what you need to write to it. And then when you're trying to read and debug, everything's in hexadecimal. It's really easy to make a simple error, and it's a nightmare to debug. And I remember saying, who would do this? Like, I can do this in hardware much faster. And now, these days, with things like Arduino, taking off in the early 2000s, and now we have things like our Microchip code configurator, which enables you to set up your peripherals quite easily and just start working with them. That the change in just that amount of time has been truly impressive.
So you mentioned a few interesting things there. Suppose one of our listeners has a use case for this technology. Where would they go? How would they adopt it? Where could we send them?
So the place that they could start is going to hackster.io, and they can use the search term agricultural IoT and look for the article by Toby Sinkinson, who's with me right here. And the version there is based on development boards where you can buy all these bits and pieces online, cobble it all together, and get a prototype up and running. And so from there, once you're happy with the way your prototype is going, then if you want to, you can lay out your own printed circuit board. You can adapt it for any other things that you might want to measure, and just run with it from there.
We'll make sure we include a link to that in the show notes. So we kind of have a state of where we are now. The cost is coming down, less complexity in the systems, a lot more ease of use. Farmer can walk around with a tablet, and they've got a dashboard with some basic feedback of what the soil's doing, what the air's doing. We've got microclimates. Where's the future going? What are we looking at, 5, 10, 20 years down the road? What are we looking at next year? Any ideas of where the direction is that we can go? What are we looking forward to?
I know what I'd like to see. I'd like to see distributed farming, so we were talking about that earlier, is farming the food closer to where it's going to be consumed. And a way that can potentially be done in cities is doing hydroponic rooftop farming. So that enables you to do vertical farms, so you can pack in a lot more produce being grown into the same area that you would be using with soil. And it used to be that all of the hydroponic fertilizers were chemical-based fertilizers, and so they can be harmful for the environment once you've finished using them. But there's been a big rise in the last 20 years or so, I guess, of using more organically based fertilizers. And this is like creating worm castings tea, and you add some bat guano and some liquid kelp fertilizer and some blackstrap molasses and bubble it in a bucket basically for one day to a week, and you end up with this fermented tea, and then you could just measure the concentration of that, dilute it to whatever strength you need, and use that in your hydroponic system.
To that, I would add, when we were developing our board, we were looking at some articles about how to capture soil moisture with a capacitive moisture sensor. And there's these low cost sensors that are out there, like $2, but you can buy the high end versions for $1,000 or more. But one of the articles that we found, they actually describe soil as the final frontier. And it's very much like this. So when farmers want to get a gauge of what's going on in the soil, they have, you've always had the option of taking that sample, hauling it off to a lab and getting really good data on it. But that can take 2 weeks. You've disturbed the soil. By that time, it's really, so being able to figure out, the condition of the soil, the word is in situ, right there in that place, is still this tough problem. And there's, I think, but, given these, social pressures and climate pressures, I think there are a lot more minds are coming at this. We've seen some pretty cool different ways of trying to gather that information where you don't disturb the soil, where you can continue to farm, where you have your process is driving over that soil. So you can't have something that's going to get damaged. You can't have something that's going to degrade and harm the soil. So there's a lot of really tough problems still there. So, and I think that's an exciting place to be. It's an exciting place to see innovation happen.
Any final thoughts on this subject? We covered a lot of ground today, but any parting thoughts?
So I'm hoping that we're going to see more smaller farmers remain viable without being dominated by the extremely large farms, so that way you can get more of a relationship with your local farmer. To keep them viable, we can also improve our water consumption while improving the quality and quantity of the crop yields. And all this time, hopefully, particularly with the smaller scale farmers, is enabling them to get reasonable margins on their produce so they can remain viable and remain sustainable for their future as well, and for their children, etc. Because at the end of every day, we're recommended that we eat 5 servings of fruit and vegetable a day to lower our chance of developing chronic diseases. And and there's some evidence that may extend your longevity, but we do know it reduces the risk of death from heart and respiratory diseases. So we need to eat plenty of fruits and vegetables. So, and try to minimize our processed food. So if we can do that while helping those farmers remain viable, I think maybe there's hope for us yet.
Ross Satchell and Toby Sinkinson are application engineers at Microchip Technology, working out of the 8-bit microcontroller business unit. They join us today from our global headquarters in Chandler, Arizona. Thanks for coming, guys.
Thanks for having us.
Thank you for venturing beyond the microchip with us. Join us next time as we continue to explore empowering innovation to enhance the human experience.